Okay, we're back. So this is note 6.4, day 2, part 2. And at the end of notes part 1, we did number 9, and we graphed. This ended up to be a circle with a center at the origin. But polar curves are actually just special cases of parametric curves. And since we know that x equals r cos theta and y equals r sine theta, then for a polar function r equals f of theta, parametrically, this is how you could describe it. So let's just kind of test that. Let's just kind of test that here with one that we've already done. So since r is c, wouldn't it be true then parametrically, you would have 3 cos and 3 sine theta, which graphed that parametrically before, but let's just practice with the calculator. If I go to parametric mode and I go ahead and I was in radian mode, I went from 0 to 2 pi, and if you take a look at the graph, there we go. It is a circle with a center at the origin and radius of 3. Okay, so we have been practicing graphing with the calculator a little bit. So now we are going to without a calculator. So let's start off by thinking about in function mode. Points are determined by a vertical coordinate that changes as the horizontal coordinate moves left to right. We say y depends on x. So here's y equals cosine x. But in polar mode, points are determined by a directed distance r from the pole that changes as the directed angle sweeps around the pole. That is why the graph r equals cosine theta is not going to be a cosine curve. It is going to be a circle. So we're going to explore that in the next example. Okay, so if you turn the page, here we go. So what we're going to do is we are going to look at the equations y equals 2 cos x and y equals 2 sine x in the rectangular coordinate system. And then we're going to compare that to r equals 2 cosine theta and r equals 2 sine theta in the polar coordinate system. So let's start off by doing, we'll do the red colors here and make sure that I have. Okay, so we're going to graph y equals 2 cosine x. And I want to think of some critical values. So for example, if I think of y equals 2 cosine x, and that is my red graph here. So when x is 0, right, the y value is 1. 1. So if we think of this as r equals 2 cosine theta, right, that means at 0 degrees that r value would be 1 unit away from the pole. So, or sorry, 2 units away from the pole because this is 2 cosine. So this is a 2, sorry. So 2 cosine x, that was a vertical stretch. So that would be 2. And I'm going to call this 1. I'm going to call this 2. Now, let's think about some other critical values. At 90 degrees, we know that that when you think of y equals 2 cosine x, that the y value is 0. So, okay, so at 90 degrees, our r value would be 0 because the cosine of 90 is 0. So another critical value, let's take a look at 180. At 180, we have a r value or a y value if it's 2 cosine x of negative 2. So our y value would be negative 2. So think about this. At 180, our negative 2, you would go backwards. So we have a point right here. And at 270, again, we have a y value at 0, 360, positive 2. So let's see what's happening in between those critical points. Okay, so for example, if I'm at 0 degrees, notice that my y is getting smaller and smaller and smaller, and my x value goes from 0 to 90. For example, at 45 degrees, our y value is approximately 1. So let's see, 45 degrees would be right about here. So notice that, again, our x value is getting, our y value here, it approaches 90, is getting smaller. So for example, right about here at 30 degrees, our y value is a little smaller, our r value will be a little bit smaller. What's happening is our r value is getting smaller and smaller as we approach 0. Now, when x is 90, and again, then when we go to x equals 180, notice that our y value is at 0, but now it's getting closer and closer to a negative 2. Okay, so in fact, at 135 degrees, what's right about here, our y value is -1, so 135 -1 would be approximately right here. So again, notice that r value, 90 to 180, notice that r value, or that y value here, is it's going from 0 to -2, so it's going to be a little bit smaller, a little bit smaller. So notice that we have values, and again, at 135, we had approximately -1, which should be right here. So again, our r value is getting closer and closer and closer to a -2. So we have what would be a circle. Now notice if you keep going, for example, if you start at 180, now the y value is -2, so 180, we have a r value at -2, but between 180 and 270, your r value is getting closer. It's going from -2, but it's getting closer and closer and closer to 0. So do you see how this graph is actually mapping onto itself? Because again, from 260, the r value is getting larger, and it's getting closer and closer and closer to 2. Okay, so let's go ahead now. Okay, so I switched to a blue pen, and we are now going to graph equals 2 sine of x. So again, if you look at our graph in the rectangular coordinate system for sine, the blue one, notice that our y values are between -2 and 2. And when we are at 0 degrees, our y value is a 0. So if we're graphing over here, we notice in the polar coordinate system, so that if we have a 0 degree angle, our r value is 0. Now, again, we're looking at some critical values. If we take a look at a 90 degree angle, notice that our y value is 2. And if we look at a 180 degree angle, our y value was 0, so our r value is 0. Go ahead and look at a critical value for 270 degrees. Our r value is -2. And again, at 360, we have a value at 0. What's happening in between those critical values? So if you take a look at a 45 degree angle, notice our r value would be 1, so that would be right about here. And notice as we're going from 0 to 45, our r value is getting, our y value in the Cartesian coordinate system is getting larger. So we notice that our r value is getting larger. And from 45 degrees to 90 degrees, again, in the Cartesian coordinate system, the y value is getting larger, the r value is getting larger, getting closer and closer to 2. Now, when you go from 90 degrees to 180 degrees, notice that that's going from 2, and it's getting closer and closer to 0. So the same thing is happening over here with our r value. As we're looking at angles between 90 and 180, our r value, if you graph the values from x equals 180 to 270, notice those r values are going from 0, and they're getting closer and closer to a -2, just like our y values on the coordinate system. Rectangular coordinate system are going from 0 to -2. So you end up with a circle. Okay, let's do a couple examples. So if we're going to practice a little bit, let's just go ahead and practice. So I'd go ahead and stop the video and see if you could fill in the graphs for 11A, B, and C. Okay, so let's see how you did. So did you have, for r equals -5 and r equals 5, did you have the same graph? Because if you think about it, they are, we're graphing, and r is always 5. So our angle can be anything, but our distance, our directed distance r from the pole. Something else you might want to think about is, for this particular graph, r equals 5, at 0, we actually have a point right here. And notice that our graph is graphing counterclockwise, because at 90 degrees, again, because we're going to go to 360. But there you go. But for this other graph, for part B, you think about the graph. At 0 degrees, -5. So you actually have a starting point over here, because you went backwards when you went to 0. And then 90 degrees, we would go 90 degrees. Our r is -5. So notice we're still graphing in that counterclockwise direction, but we had a different starting point. And for part C, my angle is -7 pi over 6. So this is actually a line. Okay, for number 12, I went ahead and found some critical values and I plotted a few points. So we'll take a look at the circle that we have graphed and notice that we have at 0 degrees, our R is 2. That's our starting point right here. So I'm go ahead and pause the video and go ahead and graph the other 3 graphs by again finding critical points, point some graphs and or points graph some points and see what kind of graph you end up with. And then I want you to think about what type of symmetry you would see. And what is the R value at theta equals 0? Okay, so if you picked a few points and then you went ahead and graphed, notice that this is what our graphs look like. All circles. They all have a radius of 1 actually. And kind of interesting about looking at the symmetry, notice that the cosine graphs, the graphs with the cosine in them, they were symmetric to the x-axis. That had a sine in them, symmetric to the y. They were all in the form r equals a cos theta or r equals a sine theta, and they turned out to be a circle. Also, notice that over here, when theta was 0, r was 0. And over here, when theta was 0, r was 0. Over here, when theta was 0, r was -2. So kind of interesting where the graph starts. If you start as theta sweeps from 0 to 360. So again, we have circles.